Hey guys, welcome to 2.5 Solving Systems of Equations 3x3 Notes. So, I have a few tips for you guys, but I just need you to know ahead of time that every problem you're going to do like this works differently. Okay? Some of them are set up to be easier, some of them are not. The first thing is they have to have three equations. So basically, you're getting one equation per variable. Then number them to start off with. I would say do this if you're going to have to actually solve all the way. I'll explain what that means in just a second. And eliminate variables that have coefficients with common multiples, like 3x and 9x. Those numbers go into each other. Whereas like 5x and 9x, you would have to go all the way up to a common multiple of 45 for that. And that just is not going to be fun. I don't know if any of it's going to be fun, but that's going to be difficult to do. Okay, so you're going to basically use elimination 3 times. This is just an example. So like, let's say that you use equations 1 and 2 and you eliminate x. Then you're going to use the other two equations, like maybe the second and the third equation, and eliminate the same variable as number 4. So if you eliminate x for number 4, you're going to eliminate x for number 5. So now you have two equations that both have two variables because you eliminated one of them. Now you're going to use elimination between those two equations that you made to find the first variable. And then you use back substitution, which basically is just a fancy way of saying plugging it back in, but you have to be careful about the order you do that in. So for example, on this one, the bottom row is z equals 3. So you already know what z is. What back substitution is you have to plug it back into the row above it. So for instance, I can't plug 3 for z into this one because that doesn't help us since it's still missing two variables. So what I have to do is plug it in right here next to the 3y. And then you're going to solve this equation. I'm going to add this 3 to the other side. And then I'm going to divide by 3. And I get y equals 2. So now I know z and y, and now I'm going to find x. Now I need to plug both these back into the top one. So it'll be 2x minus 5. Get a different color because that's not working very well. Let's try again. 2x minus 5 plus 5 times 2, plus 3 times z, which is 3, equals 7. So this is negative 10 plus 9, which is negative 1. So I have 2x minus 1 equals 7, basically. I'm just solving down this part right here with the numbers that I already know. Then I add that 1 to the other side, and I get 2x equals 8. And I divide by 2, leaving me with x equals 4. And what I'm going to do on my answer key is I'm going to write it as a point with x, y, and then z. You don't have to do that. That's just what my answer key is going to look like. I am fine if you guys just leave it like this as long as you box your answers so I can see them. So that one wasn't so bad because we already knew what z was. Now let's do a system where we don't know what z is. So we have to eliminate a variable to start with, but if you notice, we already have two equations with only y and z. So what we're going to do is skip these two steps. We don't need these two new equations because we already have two equations with two variables. So we're just going to use elimination between these two, okay, between equations 2 and 3. and I want to either eliminate y or z. This one isn't as difficult. You would either need 3y and negative 3y, so you can multiply this one by negative 3. But I don't like multiplying by negatives, so what I'm going to do is get this to be 4z and negative 4z, which means that this one needs to be multiplied by 2. So I'm going to multiply that equation by 2 and write it over here. Remember, you have to multiply everything by 2, which also means you need to go slow enough that you don't forget part of it. However, sometimes mistakes happen. I do it too. And then I'm just going to bring this one. I'm not going to change it at all. I'm just going to copy it down. And then I'm going to add these two equations together. So y plus 6y is 7y. 4z plus negative 4z is 0. Good, that was the whole point. And 25 minus 18 is 7. Then I can divide by 7 on both sides, and y is 1. And we have our first variable. Then we need to do this back substitution and plug it back in. The only thing we can't plug it back into is equation 1. I am going to pick equation 2. Okay, so I'm going to plug it back into equation 2, which is this one. So y is 1 plus 4z equals 25. And then I'm going to subtract that 1 from both sides, and I get 4z equals 24. And then I'm going to divide by 4, leaving me with z equals 6. All right, now we just need to find x, which is where we're going to plug them into equation number 1. So 3x plus, instead of y, I'm going to put in a 1, minus 2, instead of z, I'm going to put in a 6, equals negative 17. And then this part right here is just 1 plus negative 12, which is negative 11. Then I'm going to add that 11 to the other side. Negative 17 plus 11 is negative 6, leaving me with x equals negative 2. And now I have my three answers. 2, 1, 6. Negative 2, 1, 6. Okay, and the way I'm writing the answer, by the way, is just like a point, but it has to have 3 parts because you have x, y, and z. All right, now, if we look at the difference between this one and this one doesn't have any of those equations that already have 2 variables. So we are going to have to do what I described up above, and I need to eliminate a variable between 2 equations and then eliminate the same variable between 2 other equations. And I don't really like the looks of this 5, 3, and 2. Those don't have a lot of numbers in common. 2, 3, and 1 isn't terrible because this is a 1, so it can easily blend in with anything else we need it to. But over here, we have negative 2 and 2. We don't even need to multiply at all on that one. And we have negative 2 and 2 here. So what I'm going to do is add the first 2 equations together and then add the bottom 2 equations together. Okay? So 5 plus 3 is 8x. Negative 2 plus 3 is 1y, positive 1y. 2 plus negative 2 is 0, and 4 plus 17 is 21. And then I'm going to do the same thing here. 3 plus 2 is 5x. 3 plus 1 is 4. There's a 1 in front of that one. And negative 2 plus 2 is 0. 17 plus 13 is 30. So now I have 2 equations, kind of like these last 2, where I only have 2 variables left. So pick 2, eliminate a variable. Pick another 2, eliminate the same variable. And then this is the last time you have to do elimination. You always have to do it 3 times unless you have nice equations like that. I need to figure out how to eliminate x or y. Not like in the looks of 8 and 5. Those don't have a lot of numbers in common. But over here we have 4 and 1. So if we could make this 4 and negative 4, we'd be golden, which means I just need to multiply it by negative 4, which I'm going to go ahead and do and write it underneath. 8 times 4 is negative 32. 1 times negative 4 is negative 4. And 21 times negative 4 is negative 84. And then I'm going to cross this one out because I don't need it anymore. And I'm going to add these together. 5 minus 32 is negative 27. These cancel. 30 minus 84 is negative 54. Don't worry, I know that 27 is a little weird, but if I divide by 27 on both sides, negative 54 divided by negative 27 is 2. We have our first variable. Now, I need to plug it back into one of these 2 equations I had right here. One of the equations that only has x and y. I'm just going to go ahead and pick this one. So 8 times 2 plus y equals 21, which is really the same thing as 16 plus y equals 21. So then I need to subtract this 16 from the 21, and I get y equals 5. And last but not least, I need to find z. So to find z, I go back over here and I pick any one of these. I'm just going to pick the top one to keep things simple. 5, and then instead of x, 2. Minus 2 instead of y, put a 5. Plus 2z equals 4. That's a 2z, by the way, not 22. So really I have 10 minus, oh look at that, 10 plus 2z equals 4. These 2 are 0, so they kind of canceled each other out, which was nice. And 2z equals 4, which means z equals 2. So my final answer is 2, 5, 2. Okay. If you feel like you understood that, you can stop here and go work on your assignment. I will do the last one on the notes, just in case someone of us needs it. All right. So, again, same thing as last time. I need to decide which variable to eliminate twice. 3, 1, and 2. With a 1 right here, that's actually not too bad. I don't really like the look of the y's because there's a 4 and a 5, and that gets a little messy. And over here, it's a little better with the 2 and the 4, but then there's this 3 up here that I'm going to have to multiply and get to 6. So I'm going to skip that, and I'm going to go ahead and just do my x's. Okay, and I'm going to use this one with the row above it, and then with the row below it. Okay, so for these two together, I want this to be 3x and negative 3x. So I need to multiply this equation by negative 3. So that's going to be negative 3x plus 6y minus 6z equals negative 30. And then I'm not going to change the top equation at all. And then I'm going to add them together. Those cancel, and I have 10y minus 3z equals negative 27. Then I'm going to come back over here, and I'm going to try and cancel out x from these two, the bottom two. So if this is 2x, I need this to be negative 2x. So what I'm going to do is multiply it by negative 2. which leaves me with negative 2x, positive 4y, negative 4z, and negative 20. Because again, I'm multiplying this entire equation by negative 2. Okay, and then I'm done with that equation for now. I don't need that. I'm going to add the new multiplied one to the bottom row. So that's going to be 0, negative 1y, negative 8z, and 11. So now I need to find a way to cancel out either my y's or my z's between these two. Okay. This one, it's not really easy, necessarily a whole lot easier one way or the other, but I see that these already have opposite signs, so this one just needs to have a 10 in front. So I'm going to multiply it by 10. Multiplying by 10 is also really easy because you just basically add zeros. So negative 10 instead of negative 1, negative 80 instead of negative 8, and 110 instead of 11. There we go. And then I'm going to add these two together. Negative 3z plus negative 80z is negative 83z. And I'm not going to lie to you today, I'm pulling out a calculator for this. Negative 27 plus 110 is 83. So don't freak out when you get weird numbers in front because a lot of times it ends up working out nicely. And then I'm dividing by negative 83, which is negative 1. And that's my z. Okay, I need to plug that back in to either one of these two equations. These two equations that I had with just y and z. I'm going to plug it back into this one because that seems a little bit easier. So negative y minus 8. Instead of z, I'm going to write negative 1 equals 11. Well, negative 8 times negative 1 is positive 8. I can subtract that 8 to the other side, and I get negative y equals 3. So y equals negative 3, because I divide by a negative at the end. Okay, and now I've got 2 out of the 3. I just need to plug them back in. The top row is pretty easy to read still, so I'm going to pick it. 3x. This is really close, so I'm going to put a line down the middle of my work. Plus 4 times negative 3 for y, plus 3, negative 1 for z, equals 3. Which turns into negative 12 minus 3, which is negative 15. So then I'm going to add this 15 to the other side and divide by 3. X equals 6, which means my final answer is 6, negative 3, negative 1. And again, I don't need this part from you. I'm fine with just having the 3 there.